Okay, so here we've got the single inverted pendulum on a cart, but now it has an implemented swing up operation that goes directly into optimal LQG control. So that has an optimal LQR, where the gains are calculated, as well as optimal estimation, where two of the four-state variables are estimated, being the cart position and the pendulum angle. So now the system itself is completely stable about its reference point, and in addition it can reject disturbances while keeping that pendulum 100% stable, and the control system is optimized to keep this link angle at 0 degrees and as stable as possible. The system can also take the reference inputs, that I just demonstrated there. It can be a bit more aggressive with them as well. But yeah, so that is the system stabilized with the additional swing up operation. As you can see, it stays completely stable and accurate about that reference position. You can come take a closer look, and you can see the stability and the lack of oscillation within the system. Also due to accuracy within the state space model. And I'll start the system